very good afternoon, students. Today, the subject is physicochemical process in water and wastewater. Okay, it's for environmental engineering. So, myself, Rehana Anjum, and I am the faculty of Chemical Engineering Department and from JNTUA CEA. Okay. Now, coming to its a first unit. Here we are going to learn about mixing and clarifications and sedimentation, agitations, gas transfer and coagulation process and colloidal particles and transport colloidal particles. Okay, now coming to a small introduction. What is physicochemical process? It means physicochemical process or the normal intracellular and extracellular physical and chemical processes that are crucial for maintenance of normal homogeneous of a cell. In general, it is a being physical and chemical properties of such a substance. Why we do this physicochemical treatment means to create a sludge and wastewater. The sludge is dewaterized in filter process and subsequently transport to a landfill, and wastewater gives the water purification plant for further treatment. Okay, that's why we are using this. Now coming to topic, it's mixing. In mixing means all you know, like mixing of two or more components like that. Okay? Mixing is an important unit operation in many phases in wastewater treatment, which includes mixing of one substance completely with another, blending of miscible liquids, flocculation of wastewater particles, continuous mixing of liquid suspensions, and heat transfer. Means most mixing operations in wastewater can be classified as continuous, um, rapid mixing in wastewater. That means continuous rapid means less than 30 seconds, or continuous means ongoing means more than 30 seconds. And next one is continuous rapid mixing and continuous rise are considered as classifications. Here, coming to classifications, first one is continuous rapid mixing in wastewater treatment. Continuous waste means rapid mixing is used most often where one substance is to be mixed with another. The principal application of continuous rapid mixing are first one is blending of chemicals with wastewater. That means means the addition of alum or iron salt um, to settle for dispersion of chlorine and hydrochloride into a wastewater for disinfections. Second one is blending of miscible liquids. The third one is addition of chemicals to sludge and biosolids to improve their dewaterization characteristics. The typical example of these mixing used in a water treated facilities given will be explained later in next slides. Now coming to mixing in waste means continuous mixing in wastewater treatment means greater than it will be greater than 30-second mixing. The continuous mixing is used where the content of a reactor or a holding tank or a basin should be kept in suspension, such as equalization basin. Means a suspended growth biological treatment process, acetates balloons, and aerobic digesters. The two applications considered in these discussions, they are in this discussion for material in suspensions. Now, coming to type of mixers used for rapid mixing in wastewater. This one is classic mixtures. Means classic mixtures means um, the continuous classic mixtures means the mixing is often one substance is to be mixed with other. Means hence here you can see the formula H is equals to K into mu square by 2G, that approximately equals to K constant mu square P equals to alpha QH. For inline mixtures are similar to a static mixtures, but continuous or um, rotating mixing elements to enhance the mixing process. Typical example of these inline mixtures are the power required for mixing is supplied by external sources. As you can see here, they are inline mixtures. This first one, A, inline mixtures. As you can see here, aligned turbulence or there, concentrated chemical feed will be entered into this. The power for mixing is supplied by a power caused by the orific plate and by the power input to a propeller mixtures. Now coming to high speed induction mixtures. As you can see here, the high speed induction efficient mixing device for a varieties of chemicals. The proper device as shown here, it's a mixing. As you can see here, E is the for chlorine mixing contains of a motor driven open propeller that creates a vacuum in the chamber directly above the propeller. The vacuum created by the impeller inducts the chemicals to be mixed directly from the storage uh, uh, container without the need for dilution of water. The high operating speed of the impeller, that means 3450 rotation per minute, provides a mixing of a chemicals that is to be added to the water by the high velocity of the solid leaving the impeller of a mixing devices. Now coming to pressurized water jets. These pressurized water jets, you can see figure F. It's pressurized water jet mixture such as shown in the figure. An important design features of pressurized water jets mixture is the velocity of jets containing the chemicals to be mixed must be sufficient to achieve mixing in all parts of pipelines. As shown, a reactor tube has been added to achieve efficiency of mixing. With pressurized jet mixer, the power for mixing is provided by external forces. Means solution of pump feed pumps. Now coming to turbine and propeller mixtures. These turbine and propeller mixtures are used commonly in wastewater treatment process for mixing and blending of chemicals for keeping material in suspensions and for agitations. The turbine or propeller mixtures are usually constructed with a vertical shift driven by a speed reducer and a electromotor. Two types of impellers are used in these. First one is First one is rapid flow impeller, second one is axial flow impellers. In these rapid flow impellers, generally we flat or curve blend located parallel to a axial of a shift. The vertical flat blend turbine impellers is a type of example for rapid flow impellers. Coming to axial flow impellers makes angle of less than 90 degrees with a drive shift, and these are classified various pinch constant angle of attack and constant pinch various angles of attacks. The propeller and hydrofoil are types of are the typical example for an axial flow impellers. Impellers mixtures may be provided with more than one set of propellers blended, and these are the types of mixer impellers used in a wastewater. Here you can see vertical flat blend turbines will be used as a turbine radial flow, and its shear is high and pumping capacity is very low, and application or vertical flow flash mixing and suspension of solids and gas dispersions. Okay, and surface impellers also flow radical and high shear and moderate pump capacity, and application for is gas transfer. And propellers or axial flow very low shear and pumping capacity is very high, and horizontal flow flash membrane mixing and suspension of solids blending and fluctuations. And these are also types of impellers with a power number, flow number, and pumping capacities. Here you can see vertical flow blend turbines having power capacity of 3.524, and flow number is 0.84 to 0.86, and pumping capacity is low. So pinched blend turbines, its angle is 40 degrees, and the power point is power number is 1.6, and flow number is 0.84 to 0.86. And coming to low shear hydrofoils, it's a three blended, its power number is 0.3, and the flow number is 0.5, and the pumping capacity is very high. And coming to blend 4, its power number is 0.6, and flow number is 0.55, and pumping capacity is high. So, up to this, it's a small introduction. I will discuss various types of impellers and propellers and fluctuations in next class. Thank you so much.